In this short video, I'm trying to accomplish the following two tasks. Task number 1, I'll discuss correlation versus causality. In terms of causality, usually we have two types of definition. The first one is common sense, A causes B. The second one is called Granger causality. So actually that is the focus of this short video. Task number 2, I'm going to use the example, chicken or eggs, who causes whom, or who Granger causes whom, to explain the concept. There are two concepts. One concept is correlation, another is causality. So here we have 7 examples. IBM stock return and Walmart stocks are positive correlate. So this is correlation. We cannot conclude which stock drive another stock's return. Example number 2, it rained yesterday, so the ground is wet today. So this is causality. Why the ground is wet? Because it rained yesterday. Because of the coronavirus, the city is shut down. So this is causality. The economy is bad. So many lost their job. This is causality. Drinking milk leads to Alzheimer's disease. Okay. So actually there are two correlations here, but example number 5 is not correct. Okay, the first correlation is drinking milk might lead to longevity. If people live longer, they have a high probability to suffer Alzheimer's disease. So causality is not correct for example number 5. Since IBM's return is positive correlated with the market, IBM's return would influence the market return. This might be true, this might not be true. So correlation is not equal to causality. Example number 7. There is correlation between ice cream sales and the temperature. This is true. If we're talking about causality, it's high temperature increase ice cream sales, not other way around. Then what is Granger causality? In words, it's defined this way. If a signal X, Granger causes a signal Y, then path value of X should contain information that helps predict Y above and beyond the information contained in the path value of Y alone. Here is the logic and two models behind our Granger causality test. For 3-factor model, we have equation number 1. Y equals alpha plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. We learned this one already. One special case is to use the legs of the same y, or dependent variable. So this is equation number 2. Instead of x1, x2, x3, we have y, leg of y, leg of y2, 2 legs of y, and 3 legs of y. So t minus 1, t minus 2, and t minus 3. We can also add another time series, leg of another time series. This is equation number 3. So we have extra beta 4, beta 5, and beta 6 to estimate. 3 legs from y and 3 legs from x. Using whether x Granger caused chicken as an illustration. First one, we have model 1. We run regression using chicken's 3 legs to predict the number of the next period's chicken. And this is model 1. So CT is chicken at time t. Beta 1, CT minus 1, CT minus 2, CT minus 3. These are 3 legs. For the model 2, we add 3 legs of x to model 1. If our conclusion is, by adding these 3 legs of x to model 1, we can predict the number of the chicken better, then we claim that X Granger cause chicken. So this is model 2. Our hypothesis is beta 4, beta 5, and beta 6. They are all 0. Please pause this video to get the data. Again, there are 3 methods to get the data. If you are taking my course right now, you can type .show chicken X. Without any input, left, right parentheses, it will show the first 2 lines. If you input 0, then you can get a whole data set. If you are not taking my course right now, you can use method 2 or method 3 to get data. For method 2, you get a CSV file. For method 3, you get Excel file. Here I show you how to use method 1 to get the data. You type .get data. See here, show chicken and eggs. Okay. Just type show chicken and eggs. Okay. If you don't enter any input, it will show the first 2 lines. If you enter 3, enter the first 3. If you enter a negative value, it will show the last 3 lines. So actually we have 54 observations. Okay, so if you enter 0, then we go to Excel and paste it there. We launch Excel, then paste it there. Next, let's run some regression. Okay, before run regression, so let's have some legs. Okay, so that's first one is chicken leg 1, called T-1. Then we have chicken leg 2 and 3. So this is chicken leg 2. So this is chicken leg 3. So this is leg 1 is equals. So this is leg 1. Then we copy and paste. And for this one is leg 2. See, 1, 2. So it's leg 2. We copy and paste. This is leg 3. Here, 1, 2, 3. So this is leg 3. And we copy and paste. Similarly, we have egg leg 1, egg leg 2, and leg 3. So this is E stands for X. So E T minus 1, E T minus 2, and E T minus 3. So similarly for this one, we have egg leg 1, we have egg leg 2, so this is 1, 2, so egg leg 2, and also we have egg leg 3, so this is 1, 2, 3. To make our final result more readable, I copy these 2 columns here. Since we are using 3 legs, our data set starting from here. Okay, I color them purple. Oh, I missed one. Okay, then I copy these labels here, 1 row above it, and I color them red. So this facilitates my regression. Okay. Here is our first hypothesis. Is chicken cause X? Okay, so this is our model 1. So model 1, we use egg against its own legs. For the model 2, we simply X against its own eggs plus chicken legs. For the model 1, we use J column against its own legs. So F, G, H columns are independent variables. For the model 2, same dependent variable, and we use 6 column as our independent variable. So let's run regression for the model 1. X against its own legs. We click data, data analysis, regression. We enter, so start from red labels, Control Shift down arrow. Then we enter independent variable. So X legs, Control Shift down arrow. Then we check the labels. To compare different results. We put them on the same spreadsheet. Okay, let's put them here. Click OK. To compare model with different number of independent variable, we use adjusted R-square. So this most important parameter. Okay. So if alpha we use 5%, then we all these compare with alpha. Obviously, intercept significant, leg 1 is also significant. So these two are not significant. So let's look at model 2. Okay, model 2, we click data, data analysis, regression. The only change is independent variable. Now we have 6 column instead of 3. Control Shift down arrow. We put the same location. Put it here. Okay. Click OK. So if you look at adjusted R-square, so this is better. Okay, so this one is better because adjusted R-square is higher than adjusted R-square. So this is we can call the 3-factor model. So this is 6-factor model. If we compare the adjusted, we look at R-square. Okay, R-square, when we increase the number of the parameter, is always high. So this is 96.7, this is 96.6. Adjusted R-square always increase with the number of the independent variable increase. However, when we compare the performance, we need to use adjusted R-square. So 3-factor model is better than 6-factor model. So let's look at chickens. Okay, so this is chicken. We have 1, 2, 3. So if we look at the p-value, you see this is higher than 5%. This is higher than 5%, higher than 5%, higher than 5%. So none of these coefficients are significant, different from 0. Chicken. do not Granger causality cause X. Or alternatively, when we add the leg of the chicken, it will not improve our predictions. Let's try the second hypothesis. Okay. To make it easy, we simply copy this one to a new spreadsheet. So this is a hypothesis. Hypothesis 2. X cause chicken. Similarly, we have model 1, actually chicken. And is a function of legs. So model 2. Model 2 is simply model 1, chicken. Okay, I'll modify this. So chicken against chicken legs plus egg legs. Okay, so we have two models, similar as before. Okay, we highlight, we make them red. Okay. Then we run regression to look at these two models. We click data analysis, then regression. And so this one is chicken. Okay, so chicken, we start from red one, Control Shift down. So chicken against its chicken's legs. So chicken, 3 column, Control Shift down. Labels, and we are going to put on the same spreadsheet. So let's put it here. Okay, so this is a model. So let's try model 2. 1. So model 2 will let's run model 2 to model 1. The only difference is we input 6 columns instead of 3. Click data, then analysis, regression. The only difference here is input X range. Before we have 3, now we have 1, 2, 3, 4, 5, 6. Control Shift down arrow. We put it here. We click OK. Now let's compare the result. Okay. And we know we should compare adjust R square, make it red, and make it red. Okay. It's 72%, now it's 78%. So this one is better. Okay. We also can look at X, the coefficient. Okay, so let's look at the p-value. Okay. For the X, one leg is statistically different from 0. Okay, so it's all this means egg Granger causes chicken.